Hello everyone, welcome once again. If you would have got a chance to see my previous sessions, we have talked about how to visualize the data that we have collected, data type, discrete data, continuous data. We looked at some of the methods to visualize the data that we have collected. We looked at a very common and a widely famous methods, like we looked at histogram, we looked at another type of method called as the scatter plots. So these two methods are very important to understand how data is spread. Another method tells us that what is the relationship between independent variable x and the dependent variable y. But there is another type of data visualization method that we use very widely. It's called as box plot. Sometimes it is called as box and whisker plot. So you can see in my screen here that a box and whisker plot helps us to understand how the data is spread from one end to the another, and it divides the data set into 4 equal quartiles. I mean, quartile means 25%. So a 25% of data similarly is divided into 4 parts of 25%. So basically divides data into 4 quartiles. So as you can see in the picture here, there is a red box. Under the red box there is a horizontal line. That horizontal line is called the median, and you will see there is a vertical line on top of it, and then vertical line starting from below. So these two vertical lines are called as the whiskers. Whiskers, you would know the whiskers that the cats and mouses have. Same whiskers we have in the box plot also. So if you look at the lower whisker, the whisker which is at the lower side, the starting of the whisker is the minimum data point in that data set, and the whisker, the another whisker, the end of that the whisker, the end point of the whisker is the maximum data point, or is the last data point in the data set. Now that is again when you sort the data from ascending to from descending to ascending, when you're sorting the data from smallest to the highest data point, that's how you get a box and whisker plot like this. So this is an anatomy of the box plot, where the first point is the whisker's first starting point, then whiskers goes on. So the length of the whisker is called as the first quartile. So wherever the first whisker ends, it touches that box. That point where it touches that box is called as quartile 1 or first quartile here. Now in that box, on that first point, it touches the box and it goes up. Now when we are going up, we get the horizontal line. So from that first point, we have the another horizontal line. The first part inside the box is another 25% or second quartile. So if you add the first quartile and add the second quartile, you get the median, which is called the 50th percentile. First quartile is also called as the 25th percentile of the data. Median, which is the horizontal line inside the box, is called as the 50th percentile of the data. Now when we are going outside the box, the point where the second whisker begins, at that point we get the third quartile, and that is where we have the 75th percentile. You might ask, where is the second quartile? Second quartile is the median. We have the first quartile, then median, which is the second quartile. Then we have the third quartile. At the third quartile, we have the 75th percentile of the data, and the last point you are already aware, which is the maximum point. So in a box plot you get 5 data points. One is the minimum data points. First quartile, you get the median, which is second quartile. Third quartile, 75th data or 75th percentile, and then the last data point, the maximum data point. So you have 5 types of data points here. Also in the box plot, when you prepare, you might get certain data points either below the lower whisker or above the upper whisker, where these data points will look like a star. Now these data points are the outliers. Now outlier is a data point that does not follow the trend in the data set, which is an extreme value. For example, if we have a data set like this, 1, 2, 3, 4, 5 values, a whisker an outlier can be, let's say, a value is 19. So 19 will be an outlier because it is not following this trend of 1, 2, 3, 4, 5. Similarly, if we have data points as 21, 22, 23, 24, 25, 5 values, and if you have a data point as 1, now this 1 is an outlier because this one is very extreme value if I compare it to 21, 22, 23, 24, 25. So in the box plot they will not fall on any of those quartiles, they will fall beyond those quartiles, like they will fall either beyond the upper whisker or beyond the lower whisker. That's where we identify the extreme values in a data set, and we call them as the outliers here. Idea is that we should always find those outliers, try to remove them first of all, and then we should do any process analysis, either if you are calculating the mean or a median or standard deviation. Idea is to first identify those outliers using the box plot and then calculate any process performance parameter. One interesting insight that we understand from box plot is the difference between the third quartile and the first quartile, or in other words, the difference between the 75th percentile and the 25th percentile, where both the whiskers, one whisker and another whisker begin, the difference between, or the total size of the box, in other words, is equal to 50%. It is also called as interquartile range. So we have first quartile and third quartile. The difference between these two quartiles is nothing but the size of the box. So that box size is also called as the interquartile range. So box plot is a very common method of understanding the process performance and how the data is spread, and it is widely used, very easy to understand also. So this is about the box plot. In the next session we'll look at a very important method of understanding the data visualization of or how the data is spread, how we can prioritize also, it can help us. So that part we'll cover as the Pareto chart in the next session. Thank you for watching. This is Shivendra Sharma.